Okay, so you've got your Arduino Uno. The first thing I want to do is get you familiar with the hardware. You'll often hear Arduinos being called microcontrollers, and that's technically incorrect. Arduinos are circuit boards that have microcontroller chips on them, but they also have a lot of other stuff on there too. Let's take a quick tour. This is the microcontroller. Arduino Unos use a series of microcontrollers called Atmega AVRs. They're made by a company called Atmel. You can buy just the bare chips on their own for about $1, but then you'd have to do a lot of soldering. Connected to the microcontroller is a crystal resonator. This controls how fast the microcontroller is running. I have a separate tutorial on resonators and oscillators which you might find useful. Now, in order to upload the software you create to the main microcontroller, there's actually another microcontroller. This chip is what lets you connect your USB cable to the Arduino board and communicate via USB. It lets you upload your programs onto the main microcontroller, and once you have your program running, this chip is what allows you to send messages back and forth between your computer and your Arduino, and this is extremely important for debugging. One great thing about Arduinos is that you can power them purely from your USB cable. But if you don't want your project always attached to a computer, you can just use an external 9-volt DC power source with a barrel jack over here. The Uno has a built-in voltage regulator that'll reduce the voltage to 5 volts. And if you ever want to reboot your Arduino's program, you've got a reset button. If you have time, it's worth studying the Arduino Uno schematic. Don't worry if it looks complicated. You don't need to understand most of it. I'm just trying to get you to understand what the Arduino designers did. They took an off-the-shelf microcontroller that requires a lot of extra parts to get working, and they put all of those things together in an easy-to-use way. And if you choose to learn more about electronics, you can create circuit boards like this too. Okay, so that's what's under the hood. Next, let's talk about the pin connectors. Over here you have the power pins. If you want, you can connect wires here to other circuitry with 5 volts or 3.3 volts. Just make sure that whatever you power doesn't draw more than a few milliamps. A few LEDs is okay, but a large motor would be an Arduino.
Boo! You suck!
TX and RX is for sending and receiving serial data. You could use this port to send and receive data from a GPS module, Bluetooth modules, Wi-Fi modules, and more. Pins 2 to 13 are for digital inputs and outputs. Normally when people think of binary, you think of just spitting out zeros and ones. But with most microcontroller pins, you can actually activate a third state and use them as a digital input. So you can use this pin as an output where it spits out 5 volts for a digital 1, or 0 volts for a digital 0, or you can internally configure the Arduino to expect a voltage on the pin, and that voltage could be interpreted as a 1 or a 0. It's a system called tri-state logic, and it's worth reading up on, but Arduino makes it really easy to change between inputs and outputs in software. Here we have 6 analog input pins, and these are used to measure continuous voltages anywhere from 0 volts to 5 volts. I'll talk more about this later in the video. Finally, some of the pins have a tilde in front of them, and this means that you can use them to output pulse width modulated square waves, which I'll also show later in the video.